Lesson 12.5, Permutations. A permutation is an arrangement in which order is important. It is important to remember that order is important in a permutation. A factorial is n factorial, it's read as n factorial. It's equal to n times n minus 1 times n minus 2 times and so on until you get to 1. Once I give the example, it will make more sense to you. Again, this is read as n factorial. That's really what you need to remember right now, is n factorial. Let me give you an example first before we do example 1. So an example of a factorial is like 5 factorial, and you would do 5 times 4, that's what 5 minus 1, times 3 times 2 times 1. And you just multiply all those together. Let's talk about permutation. 4 friends go to a movie. You can use the counting principle to count the number of permutations of 4 seats. This is the number of different orders in which 4 friends can be seated in the theater. Now remember that order is important, so it matters who sits in the first seat, who sits in the second seat. Okay, they are different seats. So the choices for the first seat is 4. The choices for the second seat is 3. Now remember that it's 3 because somebody's already sitting in the first seat. Then you have 2 and 1. Multiply together, this is 24. There's 4 friends can sit in 24 different orders. By the way, this is 4 factorial because you're taking 4 times 3 times 2 times 1. Evaluate the factorial. Remember to multiply the number times all the numbers from that number down to 1. Pause the video. For number 1, you do 2 times 1, which is 2. 5 times 4 times 3 times 2 times 1, which is 120. 7 times 6 times 5 times 4 times 3 times 2 times 1. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Example 2. 18 contestants are entered in a spelling bee. You can use the counting principle to count how many ways the top 2 finishers can advance in the finals. Now remember, it is important to know that the order does matter because you have the top finisher and you have a runner-up. There's 18 contestants, so the choices for top finisher are 18. But when you get to the second place, there's now only 17 because we already had somebody taken out for the top finisher. Multiply that together, 306 is your answer. There's 306 ways the top 2 finishers can advance. So there's 18 contestants, there's 306 ways that at least 2 of them are going to advance, or different combination or permutations of them. To find the number of permutations, you take n objects, taking it r times. It can be written like this, n permutation r, and evaluated using n factorial over n minus r factorial. So let's set this up. 6 permutation 4, we'd set it up as 6 factorial over 6 minus 4 factorial. Subtract 6 minus 4. Now let's expand the factorials. You can see when I expand the factorials, I can cross off the 2 and the 1 because they appear in both the numerator and denominator. So now all I have to multiply is 6 times 5 times 4 times 3. So let's try that in example 3. 2 students are chosen from 8 in your school science club. One of the students will attend a science fair and the other will compete in a science academic challenge. To find out how many different ways the students can be chosen, find 8 permutation 2. Again, how many total objects? That was 8. Again, this is your n objects. And then 2 of them are chosen, so this is r at a, I think it said take an r at a time. So 8 factorial over 8 minus 2 factorial, which is 6 factorial. Expand out the 8 and the 6 factorial. You can see everything from 6 down crosses off because it's in the numerator and denominator. So I'm just left with multiplying 8 times 7. You could, and this is what they're saying here, you could actually kind of save yourself a step. And instead of expanding out the entire thing, you could just say that this is 8 times 7 times 6 factorial over 6 factorial. And I stopped at the 6 factorial because that's what was in the denominator. These cancel out, and 8 times 7 is 56. It just saves yourself a little bit of work. Pause the video and try 5 through 9. Remember to use n factorial over n minus r. Subtract first, then factorial. For number 5, we have 7 factorial over 7 minus 4, which is 3 factorial. If I expand this out, stop at the 3 factorial because I'm going to cross those off. Multiply 7 times 6 times 5 times 4, which is 840. For number 6, 8 factorial over 3 factorial. Oh, I'm sorry. You actually have to subtract, excuse me. Be careful about that. 8 minus 3 is 5 factorial. So we have 8, 7, 6, and then if you can think about it, you don't even need to put the 5 factorial because that just cancels out. 8 times 7 times 5 is 336. 3 permutation 3, and that's how you do say this, 3 permutation 3. 3 factorial over 3 minus 3. Remember to subtract. 3 minus 3 is 0 factorial. So honestly what you're doing is just 3 times 2 times 1. Because this actually becomes 1. 0 factorial is 1. The reason why it's 1 is because the rule of factorial is you go from the number all the way down to 1, so you need to include that 1. Number 8, 11 factorial over 11 minus 2, which is 9 factorial. So you do 11 times 10 times 9 factorial, cross off the 9 factorials. 11 times 10 is 110. In example 1, you found the number of permutations of 4 seats taken how many at a time. So your permutation was 4 seats, permutation taken how many at a time? Well, you could say that it's 4 because all 4 seats would needed to be used by all 4 friends.